Okay, today we're going to be doing the second derivative with Ryan Bowman and Miles Ferrone. So first we're going to take our original equation, which is f of x is equal to 3x to the fifth plus 5x to the third. Oh, it's a negative 3x. Alright, so now the first step to finding the second derivative, or doing the second derivative test, is taking the derivative of our original equation. So that's going to be f prime of x is equal to negative 15x to the fourth plus 15x squared. That's a plus. Okay, now we're going to set this equation equal to 0 because it is essential to find the critical numbers for the second derivative test. So 0 is equal to negative 15x to the fourth plus 15x squared. Simplify it, we're going to factor out negative 15x squared. Now we're going to have x squared minus 1. So our critical numbers are 0, negative 1, and 1. Okay, now the second main step to the second derivative test is taking the second derivative of our original equation. So that is going to be f double prime of x is equal to negative 60x to the third plus 30x. So once we've done this step, then we're going to plug in our critical numbers that we found from putting 0 equal to the first derivative, and we'll do that for each one. So f double prime of 1 is equal to negative 60 times 1 to the third plus 30 times 1. So we get an answer of f double prime of 1 being equal to negative 30. Next we're going to do f double prime of negative 1, which is equal to negative 60 times negative 1 to the third plus 30 times negative 1. This is going to lead us to f double prime of negative 1 equaling 30. And last, we're going to plug in f double prime with 0, because that's our last critical number. Negative 60 times 0 to the third plus 30 times 0. F double prime of 0 is going to equal 0. So in context of this problem, whenever you have second derivative with the critical number plugged in and it equals 0, that means it fails for that number. Okay. So now, because f double prime of negative 1 is equal to 30, f prime of 1 is equal to negative 30. That's a 3. So with this second derivative test, if the value is negative, then it's going to be concave down in a relative max. So at f prime of 1, it's concave down. And a relative max at 1. And then you plug in 1 into the original equation, which is 2. So that's the point where you have a relative max. And for f prime of negative 1, the value is positive. So that is going to lead to a concave up with a relative min at -1, and once again we plug in the value into the original equation, which we get -2. That's a 2. Alright, so there we go. So just to go over it again, take the original equation, find the first derivative, set that equal to 0 to find the critical numbers. Then after you find the critical numbers, you want to take the second derivative, plug in your critical numbers into those values, and then if you get a negative value from the second derivative with the critical number plugged in, then it's going to be concave down and a relative max at that point. And if you get a positive value, then it's going to be concave up with a relative min. And if you get 0, then that means it fails, and that's as far as you have to go. Thank you for listening to Math with Ryan Bowman and Miles Ferrone.